All right, well, welcome everyone. I am JJ. Let's go ahead and tackle an example problem. So we're told we are just looking for our free body diagram as given. Let's make the shear moment diagrams for this. Probably the easiest way to do this is using our area method. So with the area method, I break things up into areas. I find areas of distributed loads and then areas of shear. Anytime my loading changes, I need a different area. So in this distributed load, even though it's the same height, the entire 10 feet here, this 90 kips in the middle of it means I need two different areas out. So let's label two areas. I'll have an area 1 and over here, area 2. Area 1 and area 2. Let's go ahead and find both of those areas. They're both rectangles, so I know I just want to use base times height for that. Area 1 should get me that I have area 1. Also, I've written out the rules for shear moment diagrams just to make that a little bit easier. But area 1 is my base is 6, my height is 10. Kips per foot times feet is going to get me kips, 60 kips. Area 2 is also a rectangle. Its base is 4 and its height is 10. That's going to get me 40 kips. And that's really everything that I need to make my shear diagram. So we start at the left edge and just work left to right as I go across that. So we put a dot here at 0. At 0. And then as I start to move to the left, I immediately hit this 10 kips. So I'm going to jump up to 10. As I keep going to the left, I'm constant for my loading. There's no distributed load, which means if I integrate a constant, or if I integrate 0, I get a constant. I'm going to stay at 10. My couple moment does absolutely nothing to the shear diagram, so I just move right past it. Boom. Until I get to my distributed load starts. So I can say, well, that distributed load covers area 1. So my shear at the end of area 1, that'd be out here on this dashed line, is my shear at the beginning, 10, minus the area of undistributed load. Or at the end is 10 minus 60. 10 minus 60 is going to get us to negative 50. So negative 50 out here. I have a constant value, 10, for my distributed load, which means I get a linear function here for my shear. And I know I'm going to try to figure out where am I at 0 at? What's this point right here? We'll measure that from either end of my interval, my piece here. Let's call that x1 and x2. And I need those because I need that to figure out my areas for this. But let's keep going with this piece. I'm at negative 50. I have 90 kips and area 2 at the same point. Always do the concentrated thing first. So negative 50 plus 90 is going to jump us back up here to about 40. Not about, it's exactly 40. So we'll go up to 40. Then we can say, well, our shear at the end of that is going to be the shear at the beginning, 40 minus area 2. We're coming back down to 0. Just like that. And we can shade in our diagram there to make it look nice and neat. From here, we can come in and say, well, let's break this one up into areas. So anytime something changes, I need a new area. So don't forget about our couple moments in here. That's going to mean I have to break this, even though it's the same height, into two areas. I have area 2. Sorry, not area 2. We used area 2. Area 3 and area 4. Area 3, area 4. A tiny little triangle here. We're going to call that area 5. A big triangle will be area 6. And one last triangle, area 7. To get areas 5 and 6, I need their base dimension in here. So let's use proportional triangles to figure that out. Proportional triangles tells me that my ratio of base to height in this triangle is the same as in this one because the slope's the same in here. And that'd be the same as one that goes from 10 all the way down to negative 50, and all the way over as well. So 3 pieces. I can say my x1 over my height, 10. That's base to height in my first triangle is base to height in the second. X2 over 50 will be base to height if I combine both of those. X1 plus X2 is X1 plus X2 is 6 feet. 6 divided by my change from 10 to negative 50. That's area 1, 60. And then I can solve for X1 and X2. X1 over 10 is 6 over 60. X1 is 1 foot. X2 over 50 is 6 over 60. X2 is 5 feet. And then we can keep going with all of our areas. So area 3 is a rectangle. Its base is 2. Its height is 10. This is actually going to be the same as area 4. Area 3 and area 4 are equal. Again, we just have to split them up because of that couple moment. Area 3 equals area 4 is 2 times our height is 10, or this is 20. Area 5 is a triangle. So 1/2, our base is x1, 1, and our height is 10. Or this is 5, and this would be in kip feet. Kip feet. Area 6 and 7 are also triangles. Area 6 would be 1/2. Our base is x2, 5, times our height is negative 50. Times negative 50. Or this is going to get me to negative 125 kip feet. And finally, area 7 would get me to one last triangle, 1/2. My base is 4. My height is 40. Or this is 80 kip feet. That's everything I need to really wrap this up. So we start at 0 on this. There's no couple moment here, so I don't immediately depart from 0. I should start and end at 0 when all said and done. So I can preload both of those points in here. As I start to work left to right across this, I get area 3. So my moment at the end of area 3 is the moment at the start plus the area of the shear. So 0 plus 20, I'm going to be up here at 20. So come up to 20. I had a constant for my shear, so I should integrate that, get a linear moment. At that point, I do hit my couple moment. A counterclockwise couple moment goes down. So we're going to say this point was 20. We're going to drop from 20 down by 25. So I'm going to immediately plummet and be here at negative 5. Then my next area, my moment at the end of area 4 is the moment at the beginning, negative 5, plus area 4, 20, negative 5 plus 20, brings us back up to 15. 15 right here. I'm going to label it on this side. From there, we can fill in our next piece as well. I hit area 5. So my moment at the end of this is the moment at the beginning. 15 plus area 5 plus 5. I'm going to parabola up to a max height of 20. We'll just try to make that look parabolic in there. But that continues on. Same parabola. We'll fall down by area 6. My moment at the end of area 6 is the moment at the beginning of area 6, 20, plus area 6. 20 minus 125 is going to get me all the way down here at negative 105. And we'll plot out a parabola in there. And then finally, let's try to make that look a little bit nicer. Finally, I don't know if I succeeded there. But finally, the last thing that I need is my moment at the end of This last interval at the end of area 7 is negative 105 plus area 7, or plus 80. Negative 105 plus 80 is going to get me up here to 25. I was linear for my shear, so I should have a quadratic moment that I plot in here. So quadratic, we'd look like that. We can shade the whole thing in. Finally, at the very end of that, I do have a couple moment. My couple moment was 25 clockwise. Clockwise always says go up. So we'll look up 25 from negative 25. If I jump up 25, I get back to 0, and I finish up the entire shear moment diagram. But hopefully this is a useful video for us. If it was, hit those like and subscribe buttons. Stick around, watch more videos. Let's get you in there with JJ.